Hello. How's everyone doing? How's your conference been? So hopefully you're all in the right spot. Angular unit testing from the trenches. I'm going to cover all kinds of tips and tricks of things that have tripped me up, probably have tripped you up as well. We'll get into starting points, all kinds of tips to fix those issues that you're having, all kinds of things you may not even know are there. So first and foremost, what are unit tests? It's nothing more than proof that my code does what I actually think it does. It allows me to release faster, gives me higher confidence. If I have a whole test suite, I run that, then I do my deploys. If it passes all my tests, I know that my code works exactly as I intended. So I don't have to stick around and hope that all of a sudden I don't get a bunch of user errors. I know I'm not going to. I can also refactor with ease. I've already got unit tests in place. If I refactor and all my functionality breaks, I know my refactoring didn't succeed. If I get all my tests passing, my refactor was successful. The big disclaimer though with unit testing, you only get all the advantages we're going to talk about when you get comfortable writing good unit tests. To write good unit tests, there's a few tenets. First and foremost, have to be automated. Can't count the number of times I've seen teams go, we do testing, and then they pull out a testing document that walks me step by step of where I'm supposed to click. You're never going to get developers that actually truly run through those. I also want to test a single unit. I want to test a single component, a single service. My goal is not to go from the UI all the way through the API to the database. Those aren't unit tests. Those are end-to-end tests, integration tests. I want to try to do as much of a single assumption as I can inside of my test. Granted, I violate this one a little bit myself when I do testing, but I want to keep my assumptions to exactly what's relevant to the test. I don't want to go say, let me go log in my test and make sure I got logged in and then test logout in the same exact test. I want to do logout as a whole separate test. You want to keep that whole single unit, single assumption thing going. On the proof side, we're going to prove our functionality works. We can also test for regressions. If I've already fixed a bug once and I've written the unit test, I'm going to know if I happen to accidentally re-put the bug in there, my unit test is going to start failing. It should pinpoint me right to bugs as well. I've seen tests at times where my errors just point me to a big stack trace in the testing framework. That's not helpful. I needed to point what line of code actually failed, what assertion failed. Give me that whole stack trace so I can go back through and figure out where were you at in the code? What lines actually ended up failing? And it also allows me to prove my intent. You can easily read unit test and figure out what was the code supposed to actually do. It's a great way to onboard developers, great way not to write a ton of documentation. Can't count the number of times I opened code bases that didn't do unit tests and did documentation instead, and all the docs are super out of date. Because no developer keeps the docs up to date, but you'll keep your unit test up to date. On a quality standpoint, they have to be maintainable. You want it to be dependable. No matter how many times I run them, they're going to give me the same response. They're going to run the same way. And you have to keep them in a runnable state. If you have unit tests and then you decide to write a bunch of code and not update the unit test and all you're doing is turning off your unit test in your CI, you have violated the quality principle. There's no point in unit testing if you're just going to turn them off every time they break and get back to them at some point. You always want them in a runnable state. And on the maintenance side, we don't want brittle unit test. I see this a lot when I look at UI test. Someone will say, I want div number 10 on the page. Well, if I happen to put a div somewhere in 1 through 10, all of a sudden 10 now becomes 11 and my test no longer is testing the same thing. Those are brittle test cases. You want to make sure when I make changes, my test case isn't going to break just because I made a change. It should break because I changed the functionality and I need to either refactor the unit test because that functionality went away, or I need to fix my code because it truly broke. They have to be easy to read. If you can't read and understand them, one, you won't maintain them. Two, no one's going to want to ever run them because you don't have a clue when it breaks what it's going to do. Same thing with easy to write. Angular thankfully makes it really easy to write the unit test. The easier they are to write, the more chances your team is going to actually write unit tests and keep them up to date. And you want them to be well named. They should say what they do. If I look at a login test, it should say, should log the user in. I know exactly what that test is going to do. If I just say login test, you have no clue. Are you logging in? Are you testing failures? What piece are you testing? But if I say should be logged in, you know immediately what to expect from that test. On the dependable front, consistent results. Same input should give you the same output every single time. You also have to have them isolated. If I'm testing a component, I don't want to go and test any logic in my service. If I'm testing a service, I don't want to test going to the actual database or wherever I'm getting data out of my service. I want to test just the one bit of code or piece of Angular that I'm intending to test, not the whole structure. They have to also continue to be relevant. If you refactor code, chances are you're going to refactor some tests. You remove functionality, you're going to probably remove some test cases. Don't just go comment them out because they're no longer relevant. Delete them out of the code base. Keep them up to date. You want to test the right things. We could test all kinds of functionality in the Angular space, but our goal is not to test Angular. Our goal is to test our code, and to test code that may break. And you'll see some places where I point out, if you aren't doing a lot of business logic and all you're doing is making an Angular call, there's not a point in testing that piece of code. You're just retesting Angular at that point. On the runnable side, you want them to be fast. If it takes me 10 seconds to run my test suite, I'll run them all the time. I'll even leave them running constantly. It takes me an hour to run it. You're lucky if I actually run it before I do a commit. I may not even run them before a commit. I may just let my CI server run them and fail my build because I don't want to waste an hour just watching the test run. I also want to be able to run them in a single click or a single command. I don't want to have this crazy long command that I have to try to memorize or have to put somewhere in a script or have to go in some funky UI. I want it to be really easy to run. I also want it to be repeatable. I should be able to run them as many times as I want to run them. I should be able to run them every time I make a code update. And I should get the same consistent results. We talked a bit about our failures pointed to our actual problems. And I recently saw this testing pyramid I thought was really cool. It talks about unit tests are about 70% of the cost, or 70% of what you should test, because it's the lowest level of cost, actually. As you start going up the chain, you start getting integration tests, and then you start getting the end-to-end test where you're going all the way up to the browser and down through. Those get really, really expensive. By the time you're up there running end-to-end test, you're talking in the several minutes to several hours, potentially, to go through from the browser all the way through my API to my data layer, processing that, coming back. So you want to spend the majority of your time down in this unit testing area. It's the cheapest area to catch bugs, cheapest area to run tests, and the quickest. One thing unit tests will never do is fix your bad coding practices. If you don't follow the Angular style guides and the Angular best practices, no matter how much you unit test, you're not going to be able to overcome some of those practices. But if you follow the style guide, which is really easy to follow, and their best practices that they've published tons of them on the Angular docs that are really easy to follow, unit testing will give you all your benefits. We do need a good grasp of some Angular patterns. So you need to understand modules, components, our services, our routes, our pipes, our guards. You need to know what each of these ones does. You don't need to drill down into how do they work under the covers and the in-depth, but you at least need to have a cursory knowledge. No, modules are the overall arching thing that everything falls into. Components is typically around views. Services are where you typically get data. Routes are how you get to places. Pipes are ways to affect data, like I can take in a date and transform it to some other format. And guards are about authorization, authentication kinds of things to keep me out of routes if I shouldn't be in there. From a setup standpoint, the Angular CLI is amazing. If you're not using it, you should be. It needs Node 8 now, so Angular 6 just got released last week, and they now require Node 8. Install the Angular CLI from npm, create a new app. I always like to pass in the -- style, SCSS, and -- routing, so I get a routing file and I get Sass as my style sheet. Then unit testing is baked in. It used to be that you ran npm test. With 6, they currently have a bug in the CLI that it does a single run when you run npm test and just exits your test, so you don't get to see the nice stack trace in the browser. You have to put -- watch, so it'll continue to watch that. It'll leave the browser actually up and running with Karma. Which brings us to our tools. So our test runner is Karma. It's baked into the project Angular CLI creates. And then we have Jasmine. That's the actual testing framework. That's where you're going to put your assertions, your expect statements. And then the last tool is Angular provides a bunch of testing utilities. Ways to test routes without actually hooking up all your routes. Ways to test HTTP services. Those are calls without actually making the real calls and being able to mock them out. They already provide all that stuff, so you don't have to figure out how to do it. When you run npm test, you get a command line window that looks very similar to this. It compiles, and builds your whole Angular app, and then starts running the test. It also pops up a Chrome window for you, or Chrome window I believe is what it always runs, at least in my environment, and out of the box they have it set as Karma Chrome. You can always tell it to run different browsers if you wanted to. And then it shows you every one of the specs that it's running, which is their test cases. If there's any errors, you'll see stack traces in there. You could click the debug window and open the Chrome DevTools, put breakpoints in there like you normally would. So this is a great window to be able to see what tests actually run. From a testing standpoint, we're going to jump into a whole slew of code, but now go through how do we set up tests, what do tests look like, how do we configure everything, how do we test components and routes and services. So first off, we need to know, what does a test look like? Right at the bat, everything's in a describe. It's basically a group. You can have multiple tests within a describe. You give it a name, and then you just give it a function to run. Every test is called an it. So sometimes in the Angular world, you'll see some of the people say first time to, or length it takes to get to it. How long does it take me to get to it? And they're referring to unit test. If you're in a TDD kind of environment, you want to write your unit test first. And all of them start with the it, just like the describe. You give it a name, and then you have a function. And then you have all your logic. In this case, we're expecting true to be truthy. So it will succeed like this because true is true. However, if I change that expect statement to say expect false to be truthy, we know false doesn't equal true. And so now we can see this whole stack trace that we get in here. We get the error message that says expected false to be truthy. So pinpoints us right to the problem. The stack trace is a little difficult to read. I will give you that one. As you get more uncontrived to test, you get more stack traces right into your code. From a test setup standpoint, we have things we can run before each and after each. So this is before each test, after each test. Any kind of setup, any kind of cleanup I need to do. Then you have also before all and after all. So before any test runs, and then after all of them are successful. Most testing frameworks have this kind of concept, and we'll see a ton of before each and one spot for after each. So to set up your test, we set them up in what's called a testbed. It allows us to configure a test module. So everything in Angular starts at the module standpoint. And I can import all of my components and my declarations, all my other modules, my providers. There's get references to any of those things that are injected. I can trigger my change detection right from the test bed. And I can get access to all the DOM elements. A lot of times in unit tests, you don't necessarily want to go to the DOM elements, but there are times where, so like data binding. I like to test sometimes that, did my data bind the way I wanted it to? Do I have extra spaces? Do I have extra characters? Do I have funky things that did not data bind at all? So you need access to the DOM actually to get those pieces. And from a configuration standpoint, You import Testbed from the Angular core testing module. Then you get your standard things you expect in a module. Imports, declarations, providers. And you get this one odd one called schemas. Because schemas is totally optional. What the no error schema allows us to do is to say ignore things that you don't necessarily know about. So there's times where you don't want to import everything under the sun that it may need because you're not going to be testing that. No errors is a way to try to get around that. But use it with caution though, because it can sometimes actually hide errors that you need to actually be able to see. Let's look at some real tests. So first test, just a straight component, no dependencies. So really simple component. Two things to look out for here. Out of the box, Angular does everything with an external template. No inline templates. I like that model, so I follow that for all of my coding. And then we just have a variable set to subject world. Really simple component. From a testing standpoint, first thing we have to do is configure our module. So I need to pull in async, because loading a template is an asynchronous operation. So I need to use the async testing utility. I need access to my component, which is what component fixture will give me. And then I need the testbed, which is our testing module. And then I have to import my component. Every test starts in a describe group. And for a setup, before each test, I want to do my setup. It needs to be async, like I mentioned. And now I have to declare I have a simple component, which is my component name. And I need to compile my component. So at this point, it does all my compilations. I'm ready to start interacting with it. And that's where I have to create my actual fixture. So at this point, I've just set everything up. The fixture allows me to do stuff like actually create the component. So this is what our test looks like at this point. I need to create a fixture so I can get access to the component. And then outside of my before each async, I have another before each. Luckily, with the way that Jasmine works, it'll run the async one. Once that one's done, then it'll go and run the next before each. And here's where I actually create my component. So now I have an instance in memory of that component. But I don't have access to it yet. I just created it. So I basically newed it up without access. So to get access to it, create a variable for the component. And then I want to say fixture.component instance. So this component instance gives me direct access right into the component, and now I can start interacting with it. So now I can run the most simple test, and this is the test that comes out of the box every time you generate a component. You get an it, says it should be created, and you expect the component to be truthy. That just means I was able to new up the component successfully. Most basic test that you can get for the component. As you start adding in more dependencies, you have to keep updating the test bed to add in those dependencies, else this test starts to fail because it doesn't know what your services are. It doesn't know any other components you may depend on. But it's a great test just to make sure you at least have everything set up correctly in your test. Sometimes you'll get errors in other tests, and you'll wonder, did my test fail or did my setup fail? This will tell you, did your setup fail? But at this point, all we've done is create the instance. We haven't done anything with it. Hasn't run ng on init or anything else. So we need to trigger our change detection. Once we trigger this change detection, then ng on init will actually run in our component. And it's as simple as saying fixture.detect changes. And so now I'm actually ready to start doing some testing. I can test my actual DOM. So far, this is what our tests look like. We want to import a couple other things. Out of the Angular platform browser, I want to import by. So this will allow me to do some queries that we'll see in a moment. And then debug element will actually allow me to get to the actual elements. So simple as create a variable for our debug element, say fixture.debug element, and now I'm ready to actually write some tests. So in this simple component, this is what the HTML looks like. I have a hello, and I'm binding the subject here. From a test standpoint, the standard it with our name and our function. Now I can say, for that element, go ahead and query by CSS for my h1 tag. If you have multiple H1 tags, which you should not from an accessibility standpoint, it will fail. But for stuff like this, by CSS is fantastic. I should only have one H1 tag anyway. Screen readers don't like when you have multiples. And once I have access to my H1, now I can say, give me the native element and look at the HTML properties like inner text. And I expect it to say hello world. So to recap, so our test bed is all about configuring our module. Whether we're doing components, we're doing services, we always have that test module there. Sometimes you have to import a component, sometimes you import a service. It allows us to create our components. It allows us to access DOM. We can also get injector references from the test bed using testbed.get. So anything I happen to inject, like services, it's a great way to be able to mock out your service and get access to the methods within your service if a component depends on it. And then one key thing to remember is change detection is not triggered by the created component. Guarantee that'll trip you up at least once because you'll be wondering why stuff you expected to run in ng on init didn't run when you created the component. Make sure to trigger your change detection. Let's move a little bit more advanced. Let's look at components with an actual service dependency. So simple service, we're just taking and creating a greeting service, and we're moving our hard-coded subject into the service. From a component standpoint, now we're just going to import the service, put it on our constructor, and then we'll just change our subject to say, get the subject from the actual service. However, you don't want to use real services in your test because that violates the single unit principle. Now I would be testing component and service. I just want to test the component. So to get around that, two options. You can use a stub, which basically says, I'm going to create all the same methods that my service has. And I'm going to call those, and they're going to return some bit of hard-coded data versus calling the API. You can also use Jasmine spies to say, when you run this piece, return this hard bit of data. And we'll look at both of these. So from a service stub, it looks exactly like your service. In this case, I have a subject, and I set it to test world. One big thing on this one, you want to set your stubs. If you have hard-coded data in your real service, you want to set your stubs hard-coded data to something different. That way you can truly validate, did I actually stub it out correctly? If it's all the same data, you don't really know unless you turn off your network, did I happen to accidentally call the API and go all the way through? So always make it different data. So from a testing standpoint, this is what our tests looked like before. Now we need to put on a providers on our module. Same way we do normally, except in this case, I have this funky object that says provide greeting service, use class greeting service stub. So this tells the testing module, any place that I need to use greeting service, I'm going to inject instead my stub. It's a quick way to mock it out. My test is pretty similar. The only thing that changes is my 2B now is going to look for hello test world instead of hello world. From a service spying standpoint, spies are a little bit different. So we're going to change our service up a little bit. And we're going to go the observable route. So we're going to now change our greeting, subject, and punctuation into observable. And now our component, we're going to change it up so that we have variables for all of them. And then in our ng on init, we're going to call our actual observables and get all of our data. Little contrived example, but the point around this, a lot of times in ng on init, you're doing multiple things. So now from a testing standpoint, we create our variable to get our access to our service, but our provider goes back to exactly what we're used to seeing. And then we need to get access into our actual injected service. So we can do that, there's two ways. I could create a constant variable for our test bed and access it that way, or I can say, off of the debug element, I'm an injector property, get me the greeting service. Both of them work. But now my test has changed a bit. So now I have this async property on my test. because I'm now dealing with observables, which is asynchronous operations. And now I say spy on my greeting service. Anytime I call get greeting, I'm going to return the value of observable.of hello. I need to do my detect changes. Then I need to say fixture when stable then so that it waits. And then I get to do my fixture detect changes and do my expect statements. The one bad thing with spies, this technically doesn't stop me from going directly to my service for the other two observables that are in my ng on init. So I have to remember anything that happens in the ng on init, I have to spy on that and return data, else it's going to go all the way to my service, it's going to go all the way through to my database, and it's going to bring back data. So that's the downside of spies versus service or stubs. Personally, I prefer stubs because then I'm ensured that I actually overwrote everything I needed to overwrite. But this code looks like we really don't want this kind of then kind of syntax. It really doesn't look that great. It's hard to follow. You're probably going, when does when stable actually come back? Like, I don't actually even know myself when it comes back because I like my test to look a little bit more synchronous. And we can do that with something called tick and fake async, both testing utilities Angular provides. And tick basically forwards the virtual time. So it doesn't wait for like the observables to come back. It just makes them then come back. That's why you spy on the stuff. And it all runs within the fake async, because it's not truly async. So I can do my same spy but now I say fixture.detect changes, and I say tick. And so it's going to move it forward virtually, and I detect my changes again, and now I can do my expect statement. This is much easier to follow. I know it's going to run spy on, then it's going to run my fixture detect changes, then my tick, then keep going. I don't have to wonder, well, when does when stable come back? And you can also with tick tell it how far forward you want it to go. So if you wanted to forward, say, a second, 5 seconds, maybe you have a pause in your code or you're running a timer, you can tell it to forward as far as that needs to go. We don't want to connect to our actual service. That's where the stubs or the spies come in. Definitely prefer the stubs. If you do go down the spy route, make sure you spy on everything in that ng on init. That will definitely trip you up and you'll be wondering, why is my test running so slow over something that should be so simple? And it's because you didn't spy on everything and it is truly going more integration test route. Then use the fake async in the tick instead of using the when stable. It's easier to follow, it's way less confusing. No developer in the Angular world is going to go, what does when stable do? Or actually all of them are going to go, what does when stable do? I'm not really sure. But all of them know pretty quickly what tick does, what detect changes do. They know when they're going to run. Any questions on components before we jump into reactive forms? So from a form standpoint, we're only talking reactive forms because template forms you can't actually test. If you want to test anything in template forms, you're strictly testing the HTML side of it. You can't test anything in the component because none of it's defined in the component. Where reactive forms, everything's defined in the component so you can test it. Run tests like validation errors. Is my fields valid for what I type in? Is my forms valid? Am I getting the right error messages? When I do reactive forms, I'm actually subscribing and watching the changes, and I have a generic validator routine that I run. If I want to check, did my error messages come out correctly? If I have multiple ones, did they append correctly with the right amount of spacing? I don't want to just end one error message and have it without a space onto the other error message. You can test all of that. You can test, did it display right on the UI? Just like any reactive form, pull in the form group, the form builder, the validators. Because I'm doing the generic validation routines, and I'm subscribing to the changes, I like to do debounce so that it actually waits. In this case, it's going to wait at least a second for them to stop typing before it runs the validation routine. There's nothing like from a user experience, the minute they click on a field saying, you need to, this field's required, or this is an email. It's like, yes, I just clicked on it, I haven't even typed. So debounce will allow you to wait that second for them to stop typing before you show any kind of validation messages. And from a form standpoint for all these tests, I only have one form item called item. Default value is blank, and it's got two validators. It has required and min length of 3. You'll see in a moment why I picked these two. From a test standpoint, you've got to import our reactive forms module. I like to import the abstract control versus the actual control. All of the fields inherit from abstract control. So standard import statement for the module. Because I only have one form field, there's no sense in writing this one line of code in every single one of the tests. It made sense to say, before each test, just give me access to the one field. If I have a more complex form with lots of tests on it, I'm going to look at putting this one line into each test and looking for the exact form field that I need. So the tests are kind of odd. I actually found some stuff I didn't even realize or was unexpected when I ran this first test. So standard test, I said, set my value to nothing. I thought, okay, I got required, and I got a min length of 3. Well, if it's blank, it's not required, and it's not 3. I'm thinking both of those validators are going to fire. I'm sure you probably thought the same thing, and you would be wrong just like I was. Only required actually fires when the form field's blank. And you can check these by looking at the errors for the form fields. Say, if they're defined, it means that validator fired. If it's not defined, it means it wasn't fired. So then I can check the errors fired. Did my valid flag actually get triggered, which it should have? And is my form valid or not? So that allows me to know, did I set up all of my validation correctly or not? And I can do the inverse. Because here, if I set it to one character, I've met the required, but I haven't met the min length. So I should see the opposites. Min length's defined and requires undefined. So you can keep going through all of your different validators here and checking everything. And it'll probably turn up some other things as you go through it and go, oh, I thought these were going to work this way. It's like, nope. Like, who would have guessed required and min length didn't fire when the field was blank? And it felt obvious that both would fire until I ran the test case. Because I was kind of wondering, why is my UI not showing both the first time I wrote a reactive form? And I thought, maybe I did something wrong. And then this test proved, no, I did not. But there's some gotchas. Technically in the test I showed, none of that validation actually would run. Because when you say set value, it doesn't set your dirty flag on the field, and all of my generic validation looks to see that somebody typed in the field. This is intentional. There's a comment in the Angular source code that says, we think you know what you're doing when you call set value programmatically, so we're not going to set the dirty flag automatically for you. You need to handle that. Thankfully, they expose something, and we can call it an RB4 each to say, item field.mark is dirty. Because all I'm testing is my validation, the field's always going to be dirty, so I can just safely say, just make the field dirty right off the bat and trigger the change detection. And then the set value will work exactly as I expected. That was very unexpected the first time I ran through all these tests and went, why did none of my validators fire? And I literally clicked on set value and just happened to run across that code comment. It is not well documented in their docs. It is very well documented, though, in their source code. Dealing with debounce time also causes these test cases not to run. If you run it by default like I ran it before, what you're going to get is some error message that says you still have something in the queue, which means I have an async operation that didn't actually complete. So we were supposed to wait a second before that validation fired. This is the way it used to work. Before Angular 6, maybe even 5, debounce just failed, so I had to overwrite debounce to say automatically return. Luckily, they fixed that, so now to use fake async, and I say tick, and I pass in the 1000 so it'll automatically forward the time so that the debounce will actually run for me. And then I can do all my tests like I normally would. Run my detect changes, check my value. For reactive form recap, love to test validation, my error messages. especially because I have that generic routine where I'm manually setting the messages in my component to go out to my UI. Got to realize that the dirty flag's not set when calling set value. You have to, if you're using debounce, you have to run tick and give it the number of milliseconds that's equal to your actual debounce. If you give it less than it, it will still error out because it hasn't waited long enough for debounce to run. So moving on to HTTP services. So first thing with HTTP stuff, you don't want to call your actual backend. Your goal is not to test that my service can call my database or whatever API, actually it'd be an API to a database. That's not our goal. Well, our goal is to test whatever business logic I have in the service works when I return a bit of mocked up data. And luckily, Angular gives us two fantastic utilities for it: HTTP client testing module and HTTP testing controller. So both of these allow us to mock out all of our HTTP calls. So in our standard test, import both of those from the Angular common HTTP testing module. We got our standard describe. Need access to my service, and I also need access to the HTTP testing controller. There might be for each, and you'll notice because it's not a component-based one with compile components, I don't have to run async on this. And then here, I want to set testbed configure module to a constant and import in HTTP testing module and my service provider. So this first line that's highlighted gives us the second way that we can actually get references to our injector. So earlier we ran element.injector.get. Now I can just say for testbed .get and give me my to-do service that I injected in my providers. And same thing for our testing controller. And from a testing standpoint, everything's async still. The thing that totally trips me up still mentally is the first thing I'm setting up is I'm saying service.getAll. So I'm going to call in my service the getAll method, subscribe to it, and then I'm going to check my results to this mock data that it's not in the slides, but somewhere I've defined mock data and what I actually want this service to hard-coded return. And I'm checking the length for it. So mentally I'm thinking, oh, it's an observable, I just subscribed to it, it's going to run, I haven't mocked anything yet. But with that testing module, so for the HTTP client, it doesn't actually execute your HTTP calls yet. It just queues them. So I need to set up a way to get to the request. So here I say, I expect one and I give it the URL so I can get access to that request because I could be making multiple HTTP calls. In the slides, I just abbreviated the URL, but you would need whatever that full URL that you're passing into your service normally to get your API, put that in there. And now I have access to the request. And the next thing I want to do to actually run my HTTP, I need to flush everything it's caching and tell it what data do I actually want you to return back from that HTTP call. And then the last piece that's good to run, you're not forced to run it, but HTTP controller.verify will double check that I actually flushed everything that I had queued. Since I can queue multiple HTTP calls, if I only flush one of them and not all of them, then it's going to actually fail my test and it will fail on the verify step versus just saying, hey, you still have something in queue. It's really easy to mock out my HTTP. I didn't have to do any kind of funky dependency injection. I didn't have to do any really odd mock-in. Previously, their mock backend had just a whole slew of code you had to throw in there that never quite made sense, and you were magically creating all of these HTTP responses before that. By the time you got done, you went, I have absolutely no clue what this code does. I'm just thankfully it works. Now looking at this, you know exactly what it's doing. You know I'm going to get access to my request. I'm going to pass back some fake data, and I'm going to make sure they all ran. So this came out in the 5.0 kind of time frame. It's very well documented in their docs. The other piece you can do, if you're going to run more than one HTTP test in there, I would actually move the verify call into an after each so that I can always ensure that my verify runs and I don't have to remember to throw it into every test. So take advantage of those test setup and test teardown kind of methods. So as you can see, it was a really quick jaunt through HTTP services because there's not a whole lot in the HTTP services from a testing standpoint. They made it really easy. So we don't want to call our backend. We want to use those testing module, testing controller. Got to make sure you call that verify. And then one caveat I have for HTTP testing is if all you're doing is saying http.get or .post, and you're just calling your API and returning it back, you're not doing any business logic, you're not doing any error trapping, you're not doing anything besides that, the Angular call and returning it, it doesn't make sense to me to test it. That's where to test the right things. If there's no business logic, all I'm testing is that Angular can actually make an HTTP call for me. That's not value added. But typically, you're going to have some kind of business logic in there. The minute you put an error trap in there, you need to start testing it to make sure your error handler actually ran. Questions on reactive forms or HTTP testing? Why does? Because you can, reason you have to pass the URL to the test harness is because you can have multiple HTTP calls queued up. So it needs to know which one do you actually want to take effect on right now and which request do you want to get access to. Yes, it has to be your actual URL that, so in your service somewhere, like if you say .get, the first thing you're passing is the URL to go to your actual API. So that string you pass into that request object back here has to match whatever is in your actual service. And so you have, with the expect one, it just says, I expected one call to that URL, and so it gets access to that specific request. And I'd have to do that for each request that I am making that in this service. In this case, I'm only making one call, but it's just a way to get access to the request, unfortunately. There's what you need in order to actually flush the request so you can do testing. The minute I call this flush request, that's when this subscribe actually gets executed. And that's what throws me mentally still, because normally you read this top to bottom and go, subscribe runs immediately. That's not the case. Well, subscribe technically runs, but it just queues up the HTTP call. Any other questions? So on to routing. Our goal is to test navigation, not to test the Angular router. You got to have enough faith in the frameworks that you're using that they've fully tested it, and I don't need to retest it. So I just want to test my navigation. If I take some action and I expect it to route somewhere, did it actually route somewhere? So a great example of this is authentication. If I logged in successfully, I'm going to go to the home page or go to an admin page. Did it actually route successfully? And thankfully, we can abstract all of that complexity away. They give us a router testing module. So we import that from the Angular router testing. Still in async, in this case, because I'm doing a component test. The one piece I don't like in this configure test module, if you're actually testing real routes, you got to provide the routes. And you'll notice, look carefully, every one of these components is the exact same component. This is a little bit of a hack that I do when I'm testing router stuff. I know my login page isn't going to be my header component that I'm running the test in, not going to be my sign-up component, but I don't want to have to import all of those, and I don't want to have to set up every single component that it may need in order for the real route to go through. I'm just testing. If I click a button, does it go to the login page? Or in my case, on my login page, I have a button that says, take me over to the sign-up page and vice versa. I don't care what the component is, but I have to provide it in my route in order for it to be successful. So just a little hack to get around importing lots of things I don't care about. So from a test standpoint, a few things I need to import. I want to spy on my location. I also need to get access to the location, so that'll be the browser URL. And I want to get access to all of my router links. Thankfully, they provide utilities for all of these. Like normal, I'm going to create my component, get my debug element, get my component instance, detect all of my changes. But I need to also get access to my location. So I need a location spy. I need to get it out of the injector. So I'm going to say either testbed.get or element.injector.get my location and convert it into a spy location. Then I can do stuff like query all and give me every directive on the page that's a router link, or every element that has the router link directive on it. So in this case, I'm testing a header component, so basically my menu item. A lot of times I won't test the menu, but for purposes of slides, it makes a great scenario here. First thing I do is I have a bunch of test utilities that we'll cover in a bit for advancing forward with like tick and detect changes, a helper to test what my path actually is so I don't have to keep writing the same lines of code over and over, or a helper for how do I actually click on a button. First thing I want to get access to, in this case a little bit brittle test, I want to get access to the fourth link in my menu. I haven't routed anywhere yet, so I expect my location to be my home page. Because there's no authentication or guards or anything to send me somewhere else, so I should be right on the home page. But if I click on that link to route somewhere, forward my time and do my detect changes, now I just happen to know that item number 4 should go to my sign up page. If I can just, did it actually work for me? Normally I would not test just my menu items, but depending on how complex your menu is, this example, I've only got 4 items in my menu anyway, so it's a really small menu. If I got a really big menu that's either a hierarchical menu or lots of items on there, chances are you probably want to test that to make sure you didn't screw the menu up somewhere. You didn't change some link to go somewhere else unintentionally. I've definitely seen that happen in my bigger apps, especially if you're data-driven and you get a lot of your menu out of a database. I've seen people go in the database and accidentally change the wrong menu item, and then we catch it when a user tells us, hey, why does this page go to the other page instead of where it should go? It's like, I don't want my users to catch that. So these are simple tests to write. From a helper standpoint, for my click event, I need to know what button am I actually clicking on. Am I doing a left button? Am I doing a right button? And I'm assuming the middle button is 1, because left is 0 and 2 is right. And then for my helper, it can either be a debug element or an HTML element. And I can pass in the event. By default, it's going to be a left mouse click. And I can just, if it's an HTML element, I can just call the click event on the HTML element. If not, for my debug element, I need to call trigger event handler and tell it to run the click event. So having this little helper stops me from having to remember, do I need to run .click or do I need to run trigger event handler? Now I just call click and let it do it. And this example is straight out of all of the examples on the Angular testing documentation. They don't generate this, though, as part of the Angular CLI project anymore. At one point in time, in the 2 and 4 space, this used to come with the project, and then they removed it. So I still put them back in all of my projects because it's really handy. Same thing for advanced. I actually got this out of their documentation examples. I can either take in a number or not take in a number, and then I just call tick and do my detect changes. So now I just get to say advanced instead of having to write these 2 lines of code all over the place. Just write 1. Same thing for the expect path to be. Taking my location that I want it to be, taking the actual path that it's currently at, and then I can do my check. And I can either output my path or I can output the expected failure. It's a great way to be able to put messages in here. So we want to make sure we don't test our router. We want to test our navigation pieces. Let the Angular guys test the router. We want to use our router testing module. You will still see that their documentation is all around their old router stubs and their router stub directives. And funnily enough, they actually have a comment in their docs that say, at a future guide, we will use the router testing module. So it is their way to do it. All of their samples now use it behind the scenes, but their docs still have the old way to do it. I like to set the routes to the same component so that it makes testing setup easy. So moving on to some Jasmine goodies. So we've covered all the real Angular pieces, but there's some good stuff in Jasmine and some not so great stuff. First off, what if I only run a single test or a single describe? Which happens all the time. You're trying to troubleshoot one test. You don't want to run your whole test suite. So you can just put an F in front of either the describe or the it, and it will only run those tests. And the inverse, what if I don't want to run the test? So I can put an X in front of it and an X in front of the it or describe. The downside is, and I guarantee At least one of you will check it into source code and then wonder why our test suite all of a sudden is running so quick or our code coverage dropped. If you're doing CI, you should be looking at code coverage, and if it drops more than 2 or 3%, you should be flagging a failed build. And you'll go, why are we down to like 1% all of a sudden? Because somebody checked in and either exclude all the tests or only run one test. See it all the time. But those are handy things to actually run through. You can also group test together. So say you have something that's expensive to set up. You don't want to have to set up all of that setup for every single test. Instead, you can group them. So I like to run a global describe or setup. And so at every level, you get a before each. You get all and after each and all the other test fixture setup methods. Then I can do other describes. So in the case of, if I want to do a navigation test, automatically I can run my before each. I can run all of my tests that are in there. It's a great way to segregate off functionality tests. So I know immediately, okay, I'm going to test navigation, then I'm going to do some create test, then I'm going to do some toggle menu test. So is my responsive menu actually working? And funnily enough, that we put that test in there because for a while our responsive menu actually didn't work in our app and nobody actually knew it. We thought, oh, we generated it off an internal project generation tool that had the menu. It should work. Well, they had a bug they didn't know about, so we wrote the test to make sure it doesn't come back. But at every level, I can do that segregation. So great things we can do to make that easier. One piece that totally throws me, and this is not consistent across Jasmine, to equal doesn't always, it always takes the additional message, but it doesn't always spit it out. So in this example, if I take in an object called data, expected to equal expected data, if not, I'm going to say some message. Well, when it fails, I get this instead. I don't get some message. But if you noticed earlier when we did our routing test, it had the additional message. It works in that scenario because I'm testing strings. So it's not consistent across the Jasmine framework, and it's not meant to be consistent. They said it's just luck that it runs it all with the additional message. That was not their intent, and they don't plan on supporting it. But nothing stops you from passing it in, and it totally threw me. I spent a lot of time trying to look up and troubleshoot. Why is my messages not coming out? Did I screw something up? And it's like, nope, that's just Jasmine. So F in front of everything, only run this. X means don't run it. I want to make sure not to check those into source control. Group-like tests are tests that have expensive setup cost. And those additional messages, like I mentioned, don't always work. So to wrap up here, unit test are proof that my code truly does what I think it does. I can release faster. I have higher confidence. I can refactor with ease. I know all my functionality works exactly the way that I expect it to work. And make sure no bugs that I already fixed come back. I can pinpoint any new bugs right where it's at in the code. It's a great way to document functionality. First thing that you typically do when you come on a project is you're looking through the code base. If I have test cases, I can look through the test and I understand immediately what is the code intended to actually do. Greatly speeds up your time to understanding code bases. You want to keep them fast. The faster the better. You will run them at 10 seconds versus an hour, you'll never run them. Keep them simple as well, no trickiness to them. And keep them consistent. I shouldn't cross my fingers when my test cases run and hope that my results come out to be the same as last time I ran them. And I love this quote by Martin Fowler. Don't let the fear that testing can't catch all the bugs stop you from writing tests that will catch most of the bugs. I see so many teams that go, well, I'm never going to catch everything, so I'm never going to write unit tests. It's like, but if you can catch 80% of the bugs, then you only have to focus on those 20, and those 20 are probably the hard ones that you were never getting to before that were being masked by that 80% you already tracked down. So a bunch of resources to give you. There's 2 unit testing guides in the Angular space. The first link is their main testing guide. Covers everything except HTTP testing. For whatever reason, when they came out with the HTTP client module, they moved all of the testing out of the testing guide and into the HTTP guide. They're still great docs, you just have to know to go to 2 places. Jasmine has fantastic guides. We only covered a couple of spec statements. They have a whole slew of expect statements in there. They're in different assertions. All of these slides are already online at slides.net. All of the code plus more is actually available in my GitHub repository. And it's on a branch, if you know Git at all, so it's got the tree there. This is actually part of a whole Angular workshop that I run. The workshop is actually available on my website at digitaldrummerj.me. Everything's there from a lab perspective, except unit test. Unit test only has code, but it walks you start to finish from creating an Angular app all the way through finishing it, deploying it. So if you have anybody that needs to get ramped up on that, it's a great little tutorial. You can also find me on Twitter, YouTube. Occasionally I'm on Twitch and streaming. We'll leave this up for anyone that needs to take pictures of it. And we've got just a couple minutes left if there's any questions that folks have. If not, thank you very much.